Hi students, today we are going to discuss about set associative mapping in our cache memory systems. So first we watch our mapping functions, how mapping is done, how it's all working. Okay, this is our cache memory system. This is our cache memory system. Actually, how it's work? We'll now discuss it. First of all, here is three types of memory. One is our inside the cache. Actually, there is three partition. Okay, one partition for cache tag memory, and another one is for cache data memory, and another one is cache controller. Okay, uh, cache tag memory, but it hold the tag addresses. It hold the tag addresses. Okay, and then cache data memory, it hold the actual data. It hold the actual data. Then this is our cache controller. Okay, a cache controller is extra bit, hold extra bit or control the manage the cache. Okay, how it manage the cache? Cache controller helps in our cache replacement policy, then identify valid bit and update bit, data bit, all these. And cache tag address have a vital role. What is the role? Actually, the CPU send the address, the data needed is in this address of main memory location. Then the address reach to the address match logic. Okay, address match logic. And then our cache controller search the address in the cache tag memory. If the address found, then it is clear that the data is present. The data is present. Then if the tag is found, then it goes to the data where the data is placed. Then from data it is given to the data bus. Okay, all this actually happen like this. Okay, we have discussed about the cache partition. Actually, I have discussed in previous videos that here is a tag and here is data and here is some metadata bit. Actually, metadata is both two bits are metadata. One is data and another one is metadata. It holds the tag, means the addresses of the data in main memory, and then it holds like our as I tell our valid bit or data bit or another bits. Okay, then let's move to our set associative mapping. Set associative mapping is a hybrid approach. Hybrid approach means a mixed approach. What is a mixed approach? Mixed approach means here mixed approach is for we have implemented here both direct mapping and fully associative mapping. Okay, here we have both integrated direct mapping and fully associated mapping simultaneously. Okay, set associative mapping, so called a hybrid approach of direct mapping and fully associative mapping. Okay, here one thing is introduced, that is set. Okay, a set is introduced. First, set is introduced. Okay, here I have already done some diagrams. Let's zoom it for some better. Okay, let's zoom it. Okay, you can watch this diagram. Simple. These are sets. These are set 1, then set 2, then set 3. Set is a new concept here introduced, and nothing. It just helps us to indexing. Okay, it helps us to indexing. Then these are the lines. These are the lines. Inside the line, these are the data blocks. These are the data blocks. These are the one data block, another data block, then third data block, fourth data block. Okay, here the line is divided into four data byte. Then here is one byte, then here is another, then here is another, then here is another. Okay, this is actually how the set associative cache looks. Another thing you ever listen, that 4-way set associative. four-way set associative. Okay, and the way here means the lines. Okay, the lines. If a set has 4 lines, then this is called four-way set associative. If same time a set has two line, then this is two-way set associative. Okay, same time a set has if 8 lines, then 8-way set associative. Okay, this is clear. There is no point for confusion that what is set associative, four-way set associative, 8-way set associative. Okay, and here is a broader diagram. Here is a broader diagram. Here it's actually it's a two-way set associative. Here is a two-way set associative. Two-way set associative. How this is? I have to tell you that this is a set. This is a set, and this is two lines. This is for lines. In set 0 there are 2 lines. In set 1 there are 3 lines. Okay, then if a single set has 2 lines, then it is two-way set associative. Then 4 lines, then four-way set associative. The lines also called ways. This lines also called ways. WYS. Okay, and then another thing, you may be asked that why this is a hybrid approach. Then how can you prove this is a hybrid approach? Okay, let's prove this is a hybrid approach. You have already discussed about direct mapping. Okay, about direct mapping, how we use in direct mapping about addressing. We just take modulus function. If you have remembered about okay, then block number modulus number of lines. This is used in direct mapping. This is used in direct mapping. Okay, a block number modulus number of lines, then it finds the line address. It finds the line address or line number. Okay, line number, like that, exactly like that. We find here the set address. How? A block number modulus number of sets. It finds the set number. Okay, then inside a set there is multiple lines. This is line 1, this is line 2. Same in set 1, this is line 1, line 2. Okay, then in direct mapping there is a problem that we can store data in line 1. Okay, one data in line 1, but can store multiple data in same line. Okay, but here this facility provides us to store multiple data in multiple lines in a single set. Okay, in direct mapping, let's move to our direct mapping. We have discussed this is associative mapping, and this is set. This is okay. This is our direct mapping. Okay, in direct mapping here. Okay, how we find this? We find the cache line by a block number mod number of cache line. Okay, we find the cache line. Okay, this is like there is only one cache line for any specific data. Okay, for only specific data there is single cache line. In set associative cache, let's move to our set associative cache. In set associative cache, there is a single set. Okay, just listen. A single set for specific data. Okay, means there are multiple data, multiple specific data can load to our single set. Okay, and how can you find the set number? We just use the modulus function. How? A block number, then modulus number of sets, and what we find? The set number, in which set number the block will be mapped. Okay, then it's easier to find the set. Okay or not? Like that we can also see the address partition. We will also see the address partition. Okay, here is the address partition for our set associative mapping. There is actually three partition. Okay, here is our tag address, here is our tag address, okay, and this is our set address. Okay, this is our set address. Okay, let's make it example that there is our let our 4 sets are available. Okay, how many sets? 4 sets available. Set 2, then set 3. If there is set 4 available, 4 sets available, then how many bits for addressing? There is 2 bits for addressing. What is 0 0, 0 1, 1 0 and 1 1. Okay, the set bits are used to locate the appropriate set in which the data may be present. Okay, the data may be present. This address partition is used to source the data inside the cache. Okay, used to source the data inside the cache. Okay, the cache controller no need to search inside the whole cache. It will just find the set address. It will find the set address and go to that set and search the tag address. If the tag address is fine, then the data is present. Then take the data. There is a cache it. Okay. If in the set address there is no tag address match, then there is a cache miss. Okay. So here actually the cache need not to search, the cache controller need not to search inside the whole cache system, inside the whole cache memory. Okay, it will only find the set address, then go for the set and search the tag address there, search the tag address. If not find, then it's miss. If find, it's a hit. Okay, that is. Then let's go towards some example. Here's like that. Here is 04080. Here is some reference pattern. Okay, reference pattern. Okay, let's example. Here is our 2 sets, set 0 and set 1. Okay, and each set 0 has 2 lines. Okay, each set has 2 lines, means 2 different data blocks can be stored in either set. Set 0 has 2 data blocks and set 1 has 2 different data blocks. Okay, then let's find how this is working. This is 0 is block number. These are the block numbers. Okay, then 0 more the number of sets. Okay, here is the number of sets is 2. In the upper diagram there is how many sets? There is 2 sets given. So 2, then it's actually 0. Then the data is stored in our 0. Then block 0 is stored in our set 0 in line 0. In set 0 there is two places, line 0 and line 1, and block 0 is loaded in line 0. Okay, after that there is reference of 4, okay, then the 4 mod 2. Why? 2 is the number of sets. It's again 0. It's also stored in set 0, and the first line is full because block 0 is loaded. Then block 4 is full. Okay, block 4 is loaded. Here block 4 is loaded. Okay, Then in third reference there is 0. There is 0. Then what? 0 mod 2. Then again 0. Then it will searched in 0. Okay, searched in 0, and there is a hit. Okay, block 0 is available, so it is a hit. Then our next reference is 8. Then 8 mod 2, it's always 0. Then again it will search in set 0. Then no block 8 find, only block 4 is present and block 0 is present, so it will replace block 8. Sorry, it will replace block 4 and store the block 8. Okay, and if you have forgotten that first here is some miss. First here is a miss. Why? These are the compulsory miss. When we start our system, there is no data is stored inside our cache, so there is a compulsory miss. Okay, here a compulsory miss is happened. Okay, you can tell also that hit ratio in our set associative mapping is 67%, and in hit ratio in fully associative mapping is 75%, and hit ratio in direct mapping is 67%. Then why we are using our set associative mapping and direct mapping? We can use fully associative mapping. It is better. It's direct mapping, it's fully associative mapping. Okay, fully associative mapping have a better hit ratio, 75%. But you can ask generally that why don't you use fully associative cache or fully associative mapping? Why we are using direct mapping or set associative mapping? Because there is actually a problem in fully associative mapping, because it is search the whole cache, and where the empty place is found is stored there. So in this searching process there are actually more comparators are involved for faster search. Okay, these comparators somehow increase the cost, and another one, while searching the whole cache it takes too long time. Okay, this due to these reasons, and cost is the main reason why we use fully associative mapping less. Okay, we use a set associative mapping and direct mapping in place of fully associative mapping. After all, it's a less hit ratio. Okay, that's for this video, and thank you.